This is Dr. SRIDHARAN from SNS College of Technology. In this lecture, we are going to see about reference electrodes. The potential of unknown electrode can be measured by coupling it with another electrode called reference electrode, whose potential is already known. So there are classified into two types: primary reference electrode and secondary reference electrode. For example, for the primary reference electrode, the important reference electrode is standard hydrogen electrode. It is very difficult to set up a hydrogen electrode. So other electrode called secondary reference electrode. Example, saturated caramel electrode. The construction of SHE, standard hydrogen electrode. It is a primary reference electrode. The EMF developed by the SHE is arbitrarily fixed as a 0 at 1 atmospheric pressure, and the value of which is treated as constant at all temperature. It is an only electrode with which the potential of all other electrodes are compared. So here we can see the SHE electrode setup. So here using for platinum foil and platinum wire and passing through the H2 gas, and use it for the electrolyte is hydrochloric acid. So it consists of a rectangular platinum foil which is connected to a platinum wire and sealed in a glass tube. The glass jacket surrounds the tube carrying the platinum foil. The jacket is closed at the top and open at the bottom. A side tube attached to the other jacket is used for the injection of hydrogen gas into the cell. This electrode, which dipped in a 1 molar hydrochloric acid solution at 25 degrees Celsius, and hydrogen gas is passed at 1 atmospheric pressure. When the electrode acts as an anode, the electrode reaction is as follows: H2 gives 2H plus electron, that is oxidation. When the electrode acts as a cathode, the electrode reaction is as follows: 2H plus 2 electron gives H2 gas, that is a reduction reaction, is represented as, we can, SHE is represented as platinum, hydrogen, that's a 1 atmospheric pressure, slash H plus at 1 molar solution, and electrode potential is 0 volt. So development of EMF of SHE: when hydrogen gas is bubbled through the solution, it is adsorbed by the platinum foil due to the adsorption of H2 gas. The equilibrium is established between H2 molecule and H plus ions. The electrode potential developed during this equilibrium is taken as 0 and treated as constant at all temperature. Limitations of SHE: it requires H2 gas and is difficult to set up and transport. It requires considerable volume of test solution. The solutions may affect the surface of the platinum electrode. It may be poisonous. The potential of electrode is altered by changing the pressure of H2 gas. So that construction of SHE is very difficult in the practical application. So we need for secondary reference electrode. So there's a SCE. It is very difficult to maintain H plus ion concentration at 1 molar and H2 gas pressure at 1 atmosphere. The platinum electrode is poisoned by the presence of impurities in the solutions or gas. So we are going to use the secondary reference electrode, for example, saturated caramel electrode. Here to overcome the limitations of SHE, the standard saturated calomel electrode is developed. This is called the secondary reference electrode. It consists of glass tube. Pure mercury is placed at the bottom of the tube and is covered with the paste of mercurous chloride. The remaining portion of the tube is filled with the saturated KCl. The bottom of the tube is sealed with the platinum wire. So this is a setup of this figure shows the setup. There is a mercury. The bottom of this tube is filled with the mercury, pure mercury. Over there, he put the mercurous chloride plus Hg paste, and top of the tube we are using the saturated potassium chloride solution. The calomel electrode is represented by Hg/Hg2Cl2 and potassium chloride K+. If the electrode acts as an anode, the reaction is 2Hg gives Hg2 2+ 2 electron, and Hg2 2+ 2Cl- gives Hg2Cl2. The net reaction 2Hg plus 2Cl- gives 2Hg2Cl2. So there is a solid state plus 2 electrons. The mercury undergo oxidation to produce mercurous ion and combine with the chloride ions to give mercurous chloride. Hence the concentration of chloride ion is decreased. The calomel electrode acts as a cathode. The reaction is 2Hg2Cl2 gives Hg2 2+ 2Cl-. So Hg2 2+ 2 electron gives 2Hg. This is a reverse of the previous reaction. The net reaction 2Hg2Cl2 plus 2 electron gives 2HgL. This is a liquid form of mercury plus 2Cl-. The mercurous ion present in the mercurous chloride undergo reduction to give the mercury. Hence the concentration of chloride ion is increased. Characteristics of calomel electrode. So what are the advantage compared with the SHE? The electrode potential of calomel electrode depends on the activity of the Cl- ions. So when the concentration of chloride ion decreases, the electrode potential of calomel electrode increases. So usually we are using for the saturated calomel electrode. We are filled with the saturated potassium chloride solution in the tube. Whereas we are change the concentration when the concentration of chloride ion decreases, the electrode potential of calomel electrode increases. So here, so some of the concentration and variation of the potential. 0.1 normality KCl, it gives 0.33 volt. 1 normality KCl solution, it gives 0.28 volt. The saturated KCl, it gives 0.24 volt at 25 degrees Celsius. The potential of calomel electrode is temperature dependent. Measurement of single electrode potential using SE. The saturated calomel electrode is coupled with another electrode whose potential is to be determined. If the reduction potential of the unknown electrode is less than the single electrode potential of calomel electrode, SE will act as a cathode. The E cell equal to E right minus E left. E cell equal to ESE minus EX. So E cell can be determined experimentally by using the potentiometer. Then EX can be calculated as follows. EX equal to ESE minus E cell. Thank you.